Hello, this is Mr. Hansen. You have in front of you on this screen a quadratic inequality, two of them actually. So we've worked a lot with quadratic equations, and you usually get two solutions when you have quadratic equations. But when you have a quadratic inequality, you're going to have a whole slew of solutions, and it's easiest to kind of show that on a number line and then to maybe write out the solutions using interval notation or inequality notation. So that's kind of where we're headed. We'll finish this video with a word problem. So let's look at the first one. This quadratic equation is in factored form. And so we're just going to solve kind of like normal as if it were an equation. So I'm going to rewrite this. X minus 3 times x plus 1 equals 0. And if we were to think about this, you know that x minus 3 would have to equal 0, or x plus 1 would have to equal 0. If either of those two binomials equal 0, then you times it by the other one and it gives you 0 for the whole thing. So we add 3 to both sides. We've got x equals 3, subtract 1, and you've got x equals negative 1. So that's as if it were an equation. The 3 and the negative 1 still help us when we're doing an inequality. So I'm going to graph them on a number line. Here's 0, 1, 2, 3, and there's negative 1 right there. And these are kind of, these are going to be boundaries, negative 1 and 3. So we're going to just do some testing. We're going to test in 3 different spots. I'm going to test negative 2, and I'm going to test at 0, and I'm going to test at 4. And you can kind of see negative 2's right there, 0's right there, and then 4's right there. They're 1 point for each region of the graph that's broken up by those boundaries. So let's start with negative 2. Negative 2 minus 3 times negative 2 plus 1 is less than 0. Let's see if that's true. We've got negative 5 times negative 1. That's positive 5, and positive 5 is not less than 0. Oh, yep, negative 5, negative 1, positive 5 is not less than 0. Positive 5 is greater than 0. So that's what you get, and it's a false statement right there. So I'm going to put a little frowny face right there. That region didn't work. Okay, let's plug in 0. 0 minus 3 times 0 plus 1 is less than 0. So we've got negative 3 times positive 1, that's negative 3. Negative 3 is less than 0, and that's a true statement. So we're going to put a happy face there. And last one, 4 minus 3 times 4 plus 1 is less than 0. Let's see, 1 times 5 would be 5, and 5 is less than 0. Again, that's a false statement, so we're going to put a sad face there. And so our solution region is all the numbers between negative 1 and 3. So let's kind of write that out. We could say, and I'm kind of running out of space, so I'm going to come over here. Negative 1 is less than x is less than 3. Or we could say from negative 1 all the way up to 3, not including negative 1 or 3. So the first one is inequality notation, and the second one is interval notation. All right, let's look at number 2. Number 2 is not in factored form, but could we factor that out? Hopefully you're seeing a possibility here. I've got x and x from the first and first, and then the last and last I'm going to go plus 3 plus 2. And if you were to multiply that out, you would get right back to the original trinomial, so we're in good shape. So I'm going to do the same thing on this one. X is going to equal negative 3, x is going to equal negative 2, and let's go ahead and just kind of plot that on a number line. So if this is a 0, negative 1, negative 2, negative 3, like that, and we've got that there and that there. Those are kind of our boundaries. So let's pick some numbers, maybe negative 4, negative 2.5, and 0. And so if we started with negative 4, and you can put it in the factored form or the trinomial form. I think the factored form is a little easier, so I'm going to do that. Negative 4 plus 3 times negative 4 plus 2 Is that bigger than or equal to 0? We've got negative 1 times negative 2. That's a positive 2, and that is bigger than 0. So 2 is greater than or equal to 0. This is a true statement. So right here, I'm going to put a little happy face right there. And negative 2.5. So negative 2.5, or again, we're plugging it in right up here. Negative 2.5 plus 3 is 0.5. And negative 2.5 plus 2 is negative 0.5. And so we times these together. Positive times negative is negative, so we get negative 0.25. And is that bigger than 0? Negative 0.25, is that bigger than 0? It isn't. It isn't bigger than 0. It's smaller than 0, so that's a false statement. So right here, frowny face, false statement. Okay, last one, we're going to plug in 0, so we end up with 0 plus 3 and 0 plus 2. So 3 times 2 is 6. Is 6 bigger than 0? Yes, it is. That's a true statement. So 6 is bigger than 0. True statement. So I'm going to put a happy face right there. So based on this, we're going to write our solutions. We're going to say negative infinity all the way up to negative 3, including negative 3, is possibility. And then we have to write the word U. That means union. So that's part of the answer. And then the other part of the answer is negative 2 to infinity, like that. And that should be a U. Sorry, that's kind of sloppy there. Okay, the other way to write it is in interval or in inequality notation. So negative infinity is less than x is less than or equal to 3. And or negative 2 is less than or equal to x is less than infinity. So that's the other way to write it there. Okay, both ways work. All right, let's take a look at another one. This time you might notice it's not factorable. There's no factors of 11 that are going to add up to 7. So we're going to do the old, you might remember this quadratic formula. Remember that 1 is A, B is 7, and C is 11. Okay, so we're going to go negative 7 plus or minus, and 7 squared is 49, minus 4 times 1 times 11, all over 2 times 1. So let's clean it up a little bit. Look inside the square root. We can say 49 minus 44, that's 45, so negative 7, plus or minus square root 45, all over 2. Okay, hopefully you see two answers in here. Negative 7 minus the square root of 45 over 2, and negative 7 plus the square root of 45 over 2. Now earlier I went to the trouble of finding a decimal approximate so we can kind of figure out the rest of this problem here. So we got negative 4.76 and negative 9.23. So I'm going to make that little line again. Here's 0, here's 2, 3, 4, about negative 4.76, 5, 6, 7, 8, 9. Here's a negative, about negative 9.23. There we go. Okay, so I'm going to plug in negative 10. That seems like it'd be an easy one to plug in. And I'm also going to plug in, let's go negative 8. And let's go 0. So when I plug in negative 10 up here, that's going to be 100 minus 70, that's 30, plus 11, that's 41. Is 41 bigger than 0? Yes, that's a true statement. So here we've got something going on there. And then I'm going to plug in negative 8. That's going to be 64. 8 times 8, 64, minus 56. 64 minus 56 plus 11. So that's 75 minus 56. That's also going to be greater than 0. So that one happens to be a true statement too. And then I'm going to plug in 0. So 0, 0, 11 is going to be greater than 0. That one's also a true statement. So you can kind of see here that this is just going to be all real numbers. All real numbers. All right, let's take a look at one last one. This is the word problem. I'm going to maybe clean up just a little bit here so we can do it fresh. It says an object is launched from the ground level directly upward at a rate of 48 meters per second. The equation for the object's height is y equals negative 16x plus 48, x squared plus 48x. For what values of x is the object at or above 32 meters? So we have y is being measuring meters, and x is measuring seconds. Okay, so how many seconds are we at or above 32 meters? So let's write it like this. Let's write 32, and this has to be greater than or equal to 32. So 32 is less than or equal to that there. And let's go ahead and get 0 alone, see if we can factor this out or something. So I'm going to subtract 32 here and subtract 32 here. I get 0 is less than or equal to negative 16x squared plus 48x minus 32. Okay, let's go ahead and factor this out. I'm going to go 0 is less than or equal to negative 16. There's an x squared plus 3x. Oh, that's a minus 3x because we pulled out a negative 16. So minus 3x. And then a plus 2, like that. And if you were to factor this out, you'd say x minus 2 times x minus 1, something like that, negative 16. So we're almost there. We can see that x would have to equal 2 for that to be 0, or x would have to equal 1. So let's make our lines here. Here's a 0, here's 1, here's 2. And here's our boundaries right there and right there. And we want to see if, let's just plug in 0 and see what happens. So when x is 0, we have negative 2 times negative 1. That's positive 2 times negative 16 would be negative 32. Well, negative 32 is not bigger than 0, so that doesn't work. Okay, now let's plug in 1.5 right there. So that's going to be negative 0.5 and 0.5, and we multiply them together, we get negative 0.25. Multiply that by 16, we get positive 4. Positive 4 is bigger than 0, so that works right there. And finally, let's do 1 bigger than 2. 3 minus 2 is 1. 3 minus 1 is 2. 1 times 2 is 2 times negative 16 is negative 32. And that does not work. So our answer is going to be from 1 to 2 seconds. We could write it like this in interval notation, or we could write it like this in inequality notation. So when is the height going to be above 32 meters? From 1 to 2 seconds. And you can kind of think of this as a parabola. So it's kind of going upward like this and downward like that. And maybe this is 32 right there. And so from 1 to 2 seconds there is when it would be above 32, when it would be this part right there. Hopefully that helps you understand quadratic inequalities a little bit better. The big idea here is making that number line and separating things up into boundaries and determining for what regions that your quadratic inequality would work. Thanks again and have a wonderful day. This is Mr. Hansen signing out.